Next topic is attributes of wearables. So wearables are devices it own on the body that often have some sensors, connectivity and computational capability. Their key attributes includes the portability, sensors and data collections with its connectivity and interactivity and connectivity with an ecosystems, and it's also having some security and then privacy. So this is the key attributes of wearables. It can be separate as physical attributes and then functional attributes. So first you have to define the tangible hardware related characteristics of wearables. It's form, factor and then size, then materials and then durability, and battery and power and sensor and display and input mechanisms, and then connectivity hardware. So the factor of event and then size is more compact and then lightweight. For example, wristband, smart glasses and smart clothing also. Then comes to when materials and durability, it's more flexible and then durable. Then comes to when battery and then power, it's an embedded with battery and it give optimized lifestyle. Then move on to the sensor, it already embedded with hardware sensors and it can be accelerometer and then heart rate monitors like that. Then move on to the displays and input mechanisms. It looks like a small screen, LED buttons and then touch sensitive surfaces. Then final one is connectivity hardware. It may be either Bluetooth or Wi-Fi or some other cellular mobiles for communication. So the next part is functional attributes. It defines the what wearables can do. So the operation they perform and the value they can be provide, the data collection and then monitoring and processing and then computations and communication with alert and interactivity and integration and then ecosystem support and personalization with security and privacy. So in security and privacy, it secure the storage and then encryptions. So these are all the key attributes of wearables. So the next one is taxonomy for wearables. It isn't structured of taxonomy wearables. It can be classified based on the function, placement and application. So the first one is by functions or any purposes. It first it's an fitness or health monitoring. It may be either smartwatch, fitness bands and heart rate monitors and sleep trackers also. So track the steps, calories, heart rate, blood pressure, oxygen saturations like that. Then move on to the medical and then clinical wearables. It glucose monitors, ECG monitors like that. It's used for a continuous patient monitoring. Then move on to the lifestyle and entertainment. It looks like smart glasses, VR headsets and smart jewelry. It's used for gaming and then augmented reality navigations and some other notifications also. Then move on to the industrial and then occupational smart helmets. It's for in safety based. So enhance the safety, productivity and situational awareness in workplaces. The next one is by form of factor and placement. So it heat worn and then wrist worn, it may be on body worn and it may be foot or leg worn or ear worn. So for example, smart earbuds, hearing air aids and bone conduction devices. And another example is foot or leg worn. So smart shoes, insoles, motion trackers for running, and another example which means AR or VR headsets, smart glasses and hearing aids, helmets with the sensors. So these are all the examples by the factor. Then by the technology or communication mode, it isn't standalone devices. It performs processing and communication independently. For example, smartwatches with LTE. And then comes to when companion devices. It's rely on smartphones and other hubs for data processing and connectivity also. Then move on to the connected, which means it is an IoT integrated. So it can be communicate with cloud platforms and smartphones, and it's an industrial IoT systems also. The final one is by interaction or interfaces. It's an direct and then indirect. It may be some voice control also. So if you want, I can make the taxonomy of wearables with branches for their functions and placements and technologies in field of usages more. It clearly shows the different types of sensors in nowadays, the latest trends in commercial wearables. As of 2025, wearable technology is focusing on personalized health and AI integration ecosystem connectivity. The Fitbit is now largely integrated into Google's ecosystem. It offers an AI powered health coach through the Pixel Watch 3. It providing the personalized fitness plans, sleep tracking and real-time health insights. So meanwhile, Samsung Galaxy Watch 8 and Ultra 2025 models, it combine advanced health monitoring such as stress and antioxidant tracking with sleek or rugged designs, larger battery and seamless integration with Samsung devices. So both brands and emphasize smart data driven health features, but the choice depends on whether user to prefer the Google's or Samsung's ecosystems. Here, the motherboard of wearable device is a compact and low power circuit that it can integrate the processing, memory, sensor and communication modules and power management. So it typically includes the SoC, that is a system on chip for computation, RAM and flash storage, multiple sensors like accelerator and then heart rate and then GPS. So wireless modules is also here, like Bluetooth or Wi-Fi like that. So it also are an interface for displays, audio and haptics. So efficient design ensures small size, energy efficiency and seamless connectivity, enabling the continuous monitoring and interactions in devices like smartwatches and then fitness trackers. So here it shows the textile based wearables in the market. Nowadays we know the trends in textile based wearables. It's based on their healthcare applications, sports and fitness and fashion lifestyles, and then military and even though in defense also. Here for example, I'm choosing Athos training systems and Zephyr means both are leading wearable technologies in sports and fitness sector. So Athos training sensors are embedded into the athletic clothing to monitor the muscle activity, heart rate, and then movement patterns, and providing real time feedback for performance optimization and then injury preventions. Then move on to the Zephyr wearables. It focuses on psychological monitoring, tracking the heart rate, re-inspirations, and then activity levels, and are widely used by athletes, coaches and even in military applications also. So both the system integrates the data analytics to help users to improve training efficiency and maintain peak performance. So the next one is the future of wearables. It's defining the research roadmap. This is in tactile and then haptic information. Both are essential for completing the task and then control applications. So its configurations having grounded type and then non-grounded type and then wearable types also. So these are all the futures of wearables research roadmap. So this diagram shows the research roadmap for wearables. Its need for a transdisciplinary approach. So why transdisciplinary, which means wearables sit at the intersections of electronics, material science, computer science, healthcare, and then human factors. So no single discipline can cover it at all. So the roadmap must integrate the contributions from multiple fields to develop usable, reliable, and then scalable devices. So the key components in that diagram is sensors. So what sensor did in this, it captures psychological and then environmental data. So the research focus miniaturization. So the research focus miniaturization, non-invasive sensing and accuracy and then reliability under any kind of movement. Then move on to the energy sources. So this role, so move on to the energy sources, it its role is powering the wearable continuously. So it may be either batteries or energy harvesting and use some low power circuit. Then comes to when manufacturing methods, its role is how devices are physically made. So the research focus 3D printing and additive manufacturing and flexible electronics and printed circuits and integrations of sensors into textiles also. Then move on to standard, it plays the role, it just enable the interoperability, safety and regular compliance. So this research, it focus the wireless communication protocols and healthcare standards and data privacy and then security. Then move on to the processor. Its role is handle and analyze the data collected by sensors. So that research focus low power microcontroller on device AI and then efficient integration with cloud platforms. Then move on to the actuators. Its role is it provide the feedback or perform the actions based on sensor data. For an example, it's a vibration monitors, a smart drug delivery protocols, and then joints for rehabilitations. So its research is focused the integration with biosignals. So the in comes to when materials, it's a foundation for wearable comfort and then performance. So it's a flexible, stretchable and then biocompatible materials. It's in smart textiles. For example, it's maybe either in waterproofs or sweat resistance coatings also. The final one is interconnections. Why the diagrams links them all. The final one is interconnections. So why the diagrams links them all, which means sensors, processes, energy resources, manufacturing methods and then actuators with its standards. So the diagram shows the future of wearables is not just about making smaller gadgets. It requires cross domain collaboration between the material scientists, engineers and computer scientists, healthcare professionals and policy makers. So it's to create wearable devices that are functional, safe, sustainable and user friendly.